Welcome to a good old math lesson with Miss Swartz. We're going to be looking at the Pythagorean Theorem today. You may have heard of it, maybe not. Just depends on if you've maybe worked with this or not. This theorem goes back quite a ways. Just to kind of introduce it, it actually was founded, I guess, or proven by a Greek mathematician and philosopher named Pythagoras. Okay, so if you wanted to look up anything about him, it isn't, the theorem is obviously named after him. Some dispute that there was many that had kind of worked with the theorem before he actually worked with it, but he was the first one to prove it, to really show that it worked every single time. So that's why it's actually obviously named after him, as you can see. So just a little bit about that. But what we're going to be working with is triangles, specifically right triangles. Okay, so it asks, how are the lengths of the sides of a right triangle related? And that is going to be all focused around the Pythagorean theorem. So let's take a look here. Okay, so this is important. You want to write this down. Sides of a right triangle. The sides of a right triangle have special names. Okay, so the legs are the sides that make up the 90-degree angle. Okay, so we have a leg here and a leg here. You obviously need two pieces to make up a right angle. So those would be called your legs. And then we have this big word here. You may or may not have heard of it, but it's called the hypotenuse. It is the side opposite of the right angle. So as you can see, it is opposite of the right angle. This is important because when we're using the Pythagorean theorem, we're going to want to know the difference between the legs and the hypotenuse. So here is the Pythagorean theorem in some words in algebra. It says in any right triangle, so it has to be a right triangle, the sum of the squares of the lengths of the legs, okay, so sum of the squares, so a squared plus b squared, is equal to the square of the length of the hypotenuse. So the sum here should be equal to the hypotenuse squared. So a lot of what you'll hear me say is a squared plus b squared equals c squared. So it'd be really good to write all of that down, draw a picture, make sure you point out the legs and the hypotenuse. So once you have the idea of this down, it's pretty simple. We just got to make sure we're using the correct side lengths of our triangles, that we're using legs for A and B, and we're using the hypotenuse for C. Alright, so we have some examples today. Our first examples just ask us, would these be right triangles? Well, for them to be right triangles, the Pythagorean theorem has to be true. So what that means for us is that a squared plus b squared equals c squared has to be true for this triangle. Okay, so as you can see, we have our right angle here, so that would mean we would have our legs, a and b, would be 2 and 3. So we plug that in, 2 squared plus 3 squared, okay, and then our hypotenuse is across from the right angle. It's going to be c squared, so 9 squared. Then we just have to do the math. So we have 2 squared, or 2 times 2, which is 4. And we have 3 squared, which is 9. And then we have 9 squared, which is 81. So 4 plus 9 is obviously not 81. So this does not work. So what that means for us is this does not form a right triangle. Okay, so another way you may see this laid out for you is a equals 3, b equals 4, c equals 5. So that makes it really easy. We just plug it into a squared plus b squared equals c squared. So we would have 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 3 times 3. 4 squared is 16, 4 times 4. 5 squared is 25. 9 plus 16 is in fact 25, so this would be a right triangle. Okay, so that's just checking to see if we have a right triangle. Then the main thing you're going to be doing is finding missing angles. So when you have a missing angle, you can use the Pythagorean theorem to help you find it. So here's our first example. It says find the length of the hypotenuse of the triangle. Okay, so every single time we're going to be using a squared plus b squared equals c squared. And as you can see, our legs form that right triangle. So 12 and 5 form the right triangle. It already tells you that you're looking for the hypotenuse of C. So we'd have 5 squared, doesn't really matter which is B and which is A, plus 12 squared equals C squared. So we want to solve. So we have 5 squared is 25, plus 12 squared is 144, and that equals C squared. Okay, so 25 plus 144 is going to be 169, and that equals C squared. All right, so we're at a point. We do not have C alone here. Okay, we have C squared, and we talked about the inverse of something squared. We kind of briefly talked about it, but would be taking the square root of it. Okay. So remember, the square root of something squared is just that number inside. So C is now alone. But if we do something to one side of the equation, we have to do it to the other. And hopefully we have the square root of 169 memorized, which would be 13. So C would equal 13 meters in this case. Okay, now you might see, if you're in Math 8, why we were memorizing all our perfect squares. All right, here's another example. For both of these, we have to find C. Okay, so we're looking for the hypotenuse. So we would do a squared plus b squared equals c squared. So we'd have 6 squared plus 8 squared equals c squared. So 36 plus 84, or sorry, 64 equals c squared. 36 plus 64 is 100, and that equals c squared. So we'll take the square root, and we get 10 equals c. Okay, same idea for this one. A squared plus b squared equals c squared. So we'd have 12 squared plus 5 squared equals c squared. So we get 144 plus 25 equals c squared. We've already done this exact same problem, so that's always good practice. And then we get 13. Okay. This one looks a little different. So instead of looking for C, we're looking for a leg. So we're going to do the same thing. We're just going to have to work a little bit more to get A alone. So we have A squared. We don't know what A is. B is going to be the other one that makes up the right angle. So 2.1 squared. And then C is going to be across from the right angle, 2.9 squared. So obviously these are decimals. If you need to use a calculator, I understand. Okay, off the top of my head, I don't normally know 2.1 times 2.1. So calculators are fine. So we're going to have A squared plus 2.1 times 2.1 is going to give us 4.41. And then we're going to have 2.9 times 2.9, which gives us 8.41. All right, so our goal is to get A alone to solve for A, so I'm going to subtract 4.1 from this side. So I have A squared equals, well, that cancels, we get 4. So now I just want to get A alone. I'm going to take the square root, so A is equal to 2. centimeters. Perfect. All right, I want you to try number 1 here. We don't have a number 2. So this one's on your own. Okay, set up the Pythagorean theorem. I will check that one when you are done. And then you have a worksheet for your homework that you can collect once you show me that problem. All right, have a wonderful day.